Applying those same ideas now to two other industries, one from software. This is an interesting one back from 1997, I believe. And it's still kind of a timeless example, which is why I like it. It's nice and simple. What we have here is a company that's a property management company. They're not even a software development company. They hire a subcontractor, in this case, to develop software for them. So it's an interesting illustration of how it really works in reality, particularly in software, where often the expert or the developer is hired as a third party or a subcontractor. What we're told is they have an existing database management system that works well with small data sets, which ideally we would quantify, but has excessive access times, which I quantify here, greater than 30 seconds on large databases, greater than 1 gigabyte. The objective is to develop a new method to double the speed of the queries. So what we're told in this case is the technological uncertainty is on limits of the environment that they're using. They're saying the way that we organize data right now, and this is prevalent in software in general, it's a common kind of question, is how do we organize and query data? So what we're told now is they use something called a relational environment. And an example of that might be an Excel spreadsheet. It's relational. If I say cell B7 equals cell B6 plus B5, that's relational. If I copy that formula from B7 to C7, it says, well, if B7 equals B5 plus B6, then C7 equals C5 plus C6. Everything's related to its position in relation to other data. Okay? It's a simple overview. So what they've done is they've set up this data and they're querying in a relational environment. And the hypothesis is maybe there's a better method to structure and query the data. So what they say is maybe instead of doing the queries that we do in a relational environment, we can use something called a packet access method that they use in the communications industry to run these queries. So they have a hypothesis that maybe the packet access method is a better query method than the relational method. And they don't get into details here, but conceivably they would run 1,000 queries through one system and maybe 1,000 queries through the other system. And what they find out, we're told, is that roughly half the queries work better, or a proportion work better under the old system, and some of the queries work faster under the new system. What we're then told that they do is they develop a hybrid technique, a method of identifying the query and saying each query that comes in, we're going to classify that query as a query that would run better under the old relational method, or we should run the packet access method in that instance. So in each instance of the query, we will identify what the better method is and use that method in that instance, and therefore they achieve their response time goals. And the Canada Revenue says that is an advancement in software development. Okay? Not the end features or functions, but the method to get to the answer. Okay? So anything where you're developing algorithms to determine what's the best method to do something, that's a strong indicator in software, the method to get to the answer rather than the final features and results. Okay, and rounding it off with the chemicals industry. Chemicals industry is one that I like because everything tends to be very tolerance driven. They can provide variables, they can provide numerics, they can provide reams of documentation. It's the opposite of software in many cases. So what we're told here in the chemicals industry example is that we want to develop analytical procedures to analyze various chemicals in our systems. And really the goal and departure from standard practice here is to minimize the batch-to-batch variability. And you see this in a lot of industries. Wherever I'm manufacturing something and I get certain inputs, typically I want to not be relying on one supplier. I want to be able to buy from various suppliers. So it doesn't really matter what I'm doing. I could be McDonald's and I could say, well, I want you to be able to walk into McDonald's in Toronto and order a Big Mac and have it taste exactly the same as a McDonald's in Moscow, Russia. And without a tremendous amount of SR&ED, because the wheat's different and the beef's different and everything's different, yet they take steps that even though the initial ingredients are different, they identify what makes those differences and they mask or remove those, so at the end of the day you don't know where the raw materials came from. It's one consistent product. So you'll see this in various industries, and the more you can identify the variances in the inputs, the more supply chains you can often use and the better price you can ultimately get. So what we're told, the technological uncertainty here is what are the fabrication conditions that cause the variances? What are the main things that if these things start to go out of whack from a norm are going to cause noticeable variations in the end product? And they hypothesize that the main ones are the metal ratio, zinc concentrations, and hydroxychlorine ratios. So what happens here is, there's our perfect test matrix. 3 or more variables. What if I vary the metal ratios? How does that affect zinc or other things? One could affect the other, or they could affect other performance issues as well. And basically we're told any of the lab testing to test how these variables or any other ones affect the ultimate performance, and to mitigate and control those would be eligible. One of the strategies that we've talked about is, and a lot of our larger clients say, you know, Dave, to sit there and describe my problems in 700 words or less now, or all the activities that I did, is very difficult without a picture or a drawing. You know, that picture tells 1,000 words. If I can say, look at this picture here and see in the top left where I have a feeder problem, then it's often very easy to explain where I'm going from there. So I have some clients who actually use the pictures as their source documents, and then they just explain what's happening. And CRA reviewers tend to love that. I've seen reviewers go in on $1 million claim and actually not even read the descriptions. They just go through the picture. Oh, hey, I bet you tried this. Hey, I bet you had these problems. Oh, I used to do this stuff. I understand where you spent $1 million. No problem. Okay? Because they've done that work, and they appreciate the issues, and they understand that, yeah, these are issues anyone would face in that industry. They're common issues, and that the client spent a reasonable amount of time. So one thing that we've done, and that other clients are looking at doing too, is really provide the CRA, when you submit the form, with a login that they can go to a secure website and basically look at all the pictures, drawing, diagrams, notes, things that you want. So you have it there, you have it on a secure FTP site, or however you want to do it, so that the reviewer can go in, look at your cost details, whatever else, the things that aren't submitted with a form, but that they'd want to see on a site review. And very often we've allowed them to do the login, and they can do their working papers from a desk review. Save the client some time and hassle. Okay, why don't we take a 5-minute break at this point? That ends the technology session of the overview. We'll reconvene, say 5 minutes from now, and start talking about eligible costs.